Hi. In the last lecture, we have seen the basics of K-map. Now let us see the 2 variable K-map, 3 variable K-map, 4, 5, up to 6 variable K-maps. Let us see. These are the rules I have given. Let us start with the 2 variable K-map. Two variable K-map means number of variables are 2. So this is the structure of 2 variable K-map. A, B, A can be 0 or 1, B can be 0 or 1. Or indirectly A can be 0 means A bar. What we are discussing, all 2 variable, 3 variable, whatever may be, all we are discussing first only SOP. Okay. Later I will take one example and I will show you PYQs questions also. Okay. A, B bar, B. Right. So here in terms of AB, 0, 0 means it indicates, this box indicates minterm 0. This box indicates minterm 1. This box indicates minterm 2. This box indicates minterm 3. 0, 0, 0, 1, 1, 0, 1, 1. This is how we read. Okay. For example, they have given one question like this. Minimize the function f of a comma b equal to sum of the minterms 0 and 1. Say a, b. What are the minterms they have given? Minterms 0 and 1. Minterms 0 means output. What is the meaning? Output is 1 for 0, 0, 0, 1. 1, 0, 1, 1 are not ones. So this is how to make a K-map. F of AB equal to sum of the minterms 0 and 1. Okay. So in place of 0, 0, we should give output 1. In place of 0, 1, we should give output 1. Okay. So minterm 0, minterm 1. Minterm 0 and minterm 1 are ones. Now how to minimize this expression? In general Boolean algebra, we can write the A bar B bar plus A bar B. We can do it. Here I told you quad is not possible. Pair is possible. Go for a pair. Now, how to write the expression for pair? I told you whatever common we should take, or indirectly, what is your f is equal to, here what is the value of this 0 means a bar, this into this is the, okay, row into column or column into row, your wish. Here a bar is common, a bar into this plus this, 0 plus 1. What is 0 plus 1? Neglect 1. Or you can understand, if these two are ones, what is the meaning? A bar into B bar plus A bar into B. Or you can say A bar is common into B bar plus B. What is B bar plus B? 1. So simply blindly, when you write the K-map, this is the pair. What is common in this pair? 0 is common, A bar. Nothing is common here, neglect. That is the simple way to write. So let me take one more example. F of AB equal to sum of the minterms, say for example 0 and 2. So now you can form a pair. Now in this pair, what is common? This is not common, only this is common. What is this? B bar, or B bar into A bar plus A, which is nothing but B bar. K-map always we should write minimized expression only, because our ultimate aim is to minimize the expression. Another, let us take f of AB equal to sum of the minterms 0, 1, 2. So 0, 1, 2. A Pomic pair. Then you may have the doubt. Sir, what about this single one? Can I take this one singly or I need to make a pair with this? I told you already, always go for maximum possibility only. So if it is a pair, no problem. Overlap like this and take. Sir, can I overlap to this? Yes, no problem. Because in earlier Boolean algebra, we have done one question. Some ABC plus ABC plus ABC. What is the answer? It is ABC only. You can add ABC any number of times, your answer will be same. Similarly, you can take a single term any number of times when it is helpful for minimization. If it is helpful for minimization, you can take the same term any number of times. Always go for maximum possibility only. So what is the function f? This is a bar. Is it clear? For this it is a bar plus, for this it is, what is this? 0 means b bar. Okay, combination, addition of these two. First two cases is this one. Yes or no? Now you can understand here. You may have the doubt, sir. You said three rules. First rule is go for maximum possibility, clear. Second rule is all ones must be covered, okay. Third rule is you should remove redundant groups. Sir, is there anything redundant here? There is nothing redundant here. I will show you redundant later. Okay, this is not meaning of redundant. It is overlapping. Redundant is a different case. I will show you with example. Okay. One more. F of a comma b equal to sum of the minterms 0 and 1, a and b, 0, 1, 0, 1, then, sorry, already we have taken 0, 1 condition, take 1, 2 condition, sum of the minterms 1 and 2. Now, is there any possibility of making pair? They are not adjacent, they are diagonal, okay. Nothing is adjacent here, okay. Adjacent must be, they must be in the row or in the column, okay. So, you cannot form any quad or any pair here. You should take single terms as it is. So, what is my function here? This single term is a is 0 means a bar into b is 1 means b plus a is 1 means a into b is 0 means b bar. Okay, earlier we have discussed this. What is this function? A XOR. Here you cannot do any minimization, whether by K-map, whether by Boolean algebra, anything. Lastly, let me take one more example. F of a comma b equal to sum of minterms 0, 1, 2, 3. So 0, 1, 2, 3. All minterms are ones. Now you can form 4 as a quad. What is the answer? Here 0 plus 1, nothing is common. 0 plus 1 is how much? 1 into 0 plus 1. Is it clear how we write this plus this into this plus this? So 0 plus 1 is 1 into 0 plus 1 is 1. So what is my answer? 1. Or you can indirectly say a bar plus a 1 into b bar plus b 1. 1 into 1 is 1. Or we know one more condition also. Sum of all minterms always give me 1 in the expression. So in this two variable case, this quad will give me what is the answer? 1. Now please understand what is the meaning of redundant. Suppose I got a quad f equal to 1 is the answer. Here don't take this again as a pair. Internally don't take two pairs. After taking a quad, your answer is finished. Don't take again one pair and write 1 plus something. 1 plus anything is always 1. Okay, in this case, if you take one more pair here, this is one example of redundant. I will show you a few more examples also. Okay, first copy this. Okay. That is about the basic two variable K-map. For understanding purpose, we can use this. Next, let us see the next one, three variable K-map. See here. This is the structure of three variable K-map. You can take AB one side, C one side, or A one side, BC one side, your wish. Eight possibilities. A0, B1. What about BC? 0, 0, 0, 1. Please understand here, I told you, we don't take 1, 0, 1, 1 format. We take the format of 1, 1, 1, 0 because of adjacency property. Is it clear now why this column row is taken as 0, 0, 0, 1, 1, 1, 1, 0, not 1, 1, 0, 1, 1? Because of adjacency property we discussed earlier. You can take like this also. AB one side, C one side, AB can be 0, 0, 0, 1, 1, 1, 1, 0 and like this if you want. Nothing wrong, both are correct. Accordingly, we take the minterms. ABC is the format 0, 0, 0, minterm 0. 0, 0, 1, minterm 1. 0, 1, 1 means minterm 3. 0, 1, 0 means minterm 2. Here 1, 0, 0 means minterm 4. 1, 0, 1, 5. 1, 1, 7. 1, 1, 0, 6. So 0, 0, 0, 0, 0, 1. 0, 1, 0, 0, 1, 1. 1, 1, 0 is 6. 1, 1, 1 is 7. 1, 0, 0 is 4. Next 1, 0, 1 is 5. Like that you can take in this manner. This is convenient to do it. Okay. You can take this format or this format according to your wish. So that is the structure of three variable K-map. Okay. This is what we follow. A, B, C. A can be 0 or 1. B can be all zeros to all ones. In the gray code format we take. This is the, each cell represents one particular minterm. Okay. Now let us take one function. Minimize f of A, B, C equal to sum of the minterms 0, 1, 2, 5, 6. Okay. Let us take this example. Or let us, okay. A, B, C. This is the structure we have discussed. 0, 0, 0, 1, 1, 1, 1, 0. So sum of the minterms 0, 1, 2, 4, 5, 6. This is the question given. Now let us do the minimization. Is there any quad possible? Not possible. Okay, I cannot form 4 adjacent cells anywhere. So take a pair. Take a pair. This one is left over. For this one, you take like this, one pair. Nothing wrong. Another way also there. Like this. We may have the doubt, sir, are they adjacent? Yes, it is cyclic adjacency code. So this and this cell are also treated adjacency. So rolling is allowed in your K-map. Overlapping is allowed. Take the same cell any number of times, and also rolling is allowed in your K-map. Here you have a choice. You can take this or you can take this. Anyone you can take as per your convenience. So here the same, we have another solution also. What is that? you can form this as a pair, this as a pair, and this also. Both are right answers here. How right, sir? Let us write it first. What is the equation for this? F equal to, first forget about this pair. Tell me for this, B bar into C. Please understand how we write. Whatever common in a row or a column, we write that. What is the common in this column? B0 C1. B0 C1 means B bar C into 0 plus 1. Neglect. Nothing is common in the column. Only in the row it is common. B bar C plus. For this, why we are taking common? All I have given already. For this, what is the answer? B into C bar plus. Now for this row, you can see A must be 0, means A bar. Here A is constant, not changing. A must be 0. And B, in these two cases, BC mein what is common? C is common as 0. C common as 0. B is 0 to 1. You can neglect because 0 plus 1 is 1. So A is 0. A bar into what is common in both? 0 is common. So C bar. What is F here? Same. This column is same. B bar C. This column is same. B C bar plus here this pair. In this pair A bar into what is common in both? B bar. Okay, because 0, B is 0 in both, C is can be neglected, so B bar. So both the answers are valid. If you have doubt, convert both of them into canonical form and check it, you get the same answer, no doubt in it. Okay, so here one important case, which one is correct, sir? Both are correct. How? Check number of literal count. Literal, not literals, literal count is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Both are having equal number of literal count. Yes or no? Both are having the expression with 3 pairs only. So both are minimized answers only. So one important point here, your K-map always gives minimized solution, but it is not unique. K-map always gives minimized solution. It will give you the minimized answer with least possible literal count. It will give the answer, but it is not same every time. If you try the answer like this, you may get this. If you try the answer like this, you may get this. Both are technically right answers. Okay, K-map always gives minimized solution, but need not be unique. I'll give that point. First copy up to this. Right. Now let us discuss the next question in the 3 variable K-map. Okay, before that please make a note after this, write down the point. Write down. K-map always gives minimized solution. K-map always gives minimized solution, but it need not be. K-map always gives minimized solution, but it need not be unique. But it need not be unique. It need not be unique. It need not be same. Okay, right. Always gives minimized but not unique solution. Sum of the min terms. Let us take one question. Minimize the function f of ABC equal to sum of the min terms 3, 5, 6, 7. Three, 5, 6, 7. Right. Now please understand. This is a pair. I told you already, when you have 3, you cannot form a group, but you can form these 2 as one pair and these 2 as one pair. You may have the doubt, sir, can I take the same one any number of times? If it is useful for minimization, always take it, because if you write a single term, for example, your answer is A into B bar C, literal count is 3. But if you take a pair, here A is common, here C is common, AC, literal count is 2. Always our ultimate aim is to write the minimized expression. So whenever there is a possibility for pair, go for the pair or quad, whatever may be. That is the first point I have given. Always go for maximum possible grouping. Okay, right. Now what is the answer F? Tell me for this. Here for this pair, A is 1, that is A into what is common here in both, C must be 1, so AC, plus here in this pair, what is common here, 1, 1, so BC, plus you can understand B must be 1, C must be 1, but here A is not changing from 0 to 1, 0 plus 1 is 1, neglected. Okay, is it clear? Now for this pair, A is 1, so A into what is common in both, B is 1, so A into B. You can neglect 1 plus 0. So what is the answer? A into B. So what is the answer? F equal to AC plus BC plus AB. F equal to AC plus BC plus AB. It is already we discussed. What is this gate? This is called majority gate, we discussed in the Boolean algebra. There also, if you remember, I have the expression A bar BC plus A B bar C plus ABC C bar plus ABC. We added ABC 3 number of times, ABC plus ABC plus ABC, to get the solution. Here indirectly you are doing the same. In this pair, what is this term? A is 1, B is 1, C is 1. So this term is called ABC term. ABC term is bubbled 3 times or taken 3 times to get the minimized solution. Copy it. Copy the next one after this. So f of AB is equal to sum of the minterms 1, 3, 6, 7. Let us do the same question. Right. Sum of the minterms 1, 3, 6, 7. Now you observe. You can form pair. You can form pair. Okay, what is the answer? F equal to for this A bar into what is common? 1 is common means C. Here A into what is common? 1 is common at the position of B. So you can say AB plus for this pair A into B plus for this pair A bar into C. But if you remember, if you find one more possibility, there is a possibility of forming a pair like this. You may have the doubt, sir, can I take that pair? Why you have not considered that pair? See, this is what we call it as redundant. Now you can understand the definition of the redundant. Why it is called redundant? Why this is not called as redundant? Please see. In this pair contains two ones. Both the ones are already taken by some other pairs. Our requirement, every minterm must be covered by at least once. Every minterm must be covered at least once is my requirement. Already that requirement is fulfilled. You have taken this one, this taken one, all ones are already covered. By taking this pair, you are getting one extra term in the output which is not required because all ones are already given in the expression. But here, if you take this pair, you are taking this one into pair which is not covered already. Is it clear? In this pair, this one is covered already by some other pair, but this one is not covered. Na? If all ones in a particular pair are already covered, then it will become redundant. Not only one, it can be not only pair, it can be quad, anything. Then it will become redundant. Here it is not redundant. Please understand. Here it is not redundant. Here this pair is redundant. Or if you write the expression F equal to AB plus A bar C plus, what is this one? If you take this pair B into C, but you know this is equal to AB plus A bar C. Why? Because of consensus law. AB plus A bar C plus BC is equal to AB plus A bar C. So again you get the same answer or not? So here this is K-map, my output should always contain minimized expression only. We should not write this. Okay, this is what we call it as redundant. That is how to identify redundant pairs or redundant groups in your K-map. Okay, so whenever you have a doubt, sir, I need to write, consider it or not. In any case, whether I need to consider single term or pair, or whether I need to consider this one or not, simple logic is consider, write the expression. Don't consider, write the expression. Check literal count, which one is minimized, that is your answer. If you have doubt, sir, no, I don't want to take the pair, I take single term and write the expression, write it. With single term, write the expression. With pair, write the expression. Check whichever is least literal count, that is your answer. Here, what is the literal count? 1, 2, 3, 4, 5, 6. Not number of literals. Literal count. 1, 2, 3, 4, 5, 6. Always check for least literal count. Okay. So whether if you don't consider the pair, what is the answer? If you consider the pair, what is the answer? You just check it. Whatever you get, that is your answer. Okay. Copy it. So if you have doubt any time, always check for, consider it and don't consider it, write the expressions, whichever is least literal count, that is the answer. But all min terms must be covered in your expression. Right. Let us take the next one. Sum of the min terms 0, 3, 7. Zero, 3, 7. It is a pair. Here no possibility of pair. Take singleton. All are covered. So what is the answer? For singleton 0, 0, 0. A bar, B bar, C bar. For pair, here nothing is common. Here what is common? B into C. Okay. Copy it. Whenever there is no possibility, we should take the single term. Right. Let us see this question. F of ABC equal to sum of the minterms 0, 1, 3, 5, 7. So same way 0, 1, 3, 5, 7. Now see here, you can form one quad. You can form one pair. So what is the answer here? F equal to, for this pair, what is the answer? A must be 0. So A bar into what is common in both 0, 0, 0, 1. This first 0 is common, that is B bar, plus for this quad nothing is common here. Yes or no? For this quad we should check row and column. So for this quad here nothing is common here, because 0 plus 1 is 1. Here what is common here? This first last one is common, means C. That is how to write the expression for quad in the 3 variable K map. Is it clear? For row What is common? 1 is common, means C. For colon, nothing is common because 0 into 0 plus 1, A bar plus A only, A bar plus A, 1 only, you can neglect. So in the row and column, what is common, that only you should take, this into this or this into this. Copy it. Okay. Next one. F of ABC equal to sum of the minterms 0, 1, 2, 3, 4, 5, 6, 7. So what is this? If you take A, B, C, sum of 0, 1, 2, 3, 4, 5, 6, 7. Please remember, you may have the doubt, sir, can I take, firstly, if you take two quads here, this has one quad and this is one quad, what is the answer? For this quad, what is common? B bar. For this quad, what is the common? B. B bar plus B, what is the answer? 1. So, take all the 8. We call this as a octet here. Then what is the answer? Is there anything common in the column? Nothing is common. 0 plus 1 is 1. Similarly, you add all these. What is the answer you get? You take B bar common here and B common here. B bar plus B is again 1 or 1 into 1. What is the answer? Your answer is 1. You do by any method. You can take, for your understanding, you can take two quads, add it. Your answer will be again 1. But our ultimate answer will be same, and I told you already, whenever octet is possible, go for octet, go for maximum possibility only. Don't confuse, here nothing is common, in this row also nothing is common in all the terms, so you can neglect all the terms. Or if you add all this, you will get 1, you add all this, you will get 1. Adding means like this, B bar is common, C bar plus C is 1, B is common, C bar plus C is 1, B bar plus B is again 1, so 1 into 1 is equal to 1. Whenever you get one more important condition you can understand, whenever you get the K-map with all ones, your answer is 1. Because I told when we discuss about the minterms and max terms, sum of all minterms is equal to 1. Product of all max terms is equal to 0. So whenever any K-map, it can be 3 variable, 4 variable, any K-map may all ones are present, then blindly what is the answer? F equal to 1. Here this is octet, okay. Copy it. If it is a 4 variable K-map, your answers will change accordingly. We'll see that also. Okay. For 3 variable K-map, if it is an octet, answer will be 1. Copy it. Okay, right. That is about the basics of the K-map with 2 variable, 3 variables. We have a few more, 4 variable, 5 variable, 6 variable. Okay, we'll discuss in the next lecture. What is the 5 variable K-map, 4, 6 variable K-map? What is don't care condition? What is implicant? What is prime implicant? All the conditions of the K-map we'll discuss in the next lecture. Thank you.